There. Now, whatever you do is being broadcast.
Okay.
So feel free to get the full screen. All right, we're going to get started again. About 1 or 2 minutes. Just checking to make sure we've got everything. So maybe grab anybody from the hall if we've got anybody else. So the recordings will be up. I've already put the link up on Meetup. This one will be another one. I'll go in a few minutes and put the Meetup link up there too. So all the ones that we've broadcast and recorded, they'll all be up on Meetup, so you can find them from there. Other than that, I'm going to let Chris go ahead and get started. Do an introduction of yourself and tell us all about yourself. And after this, we'll have a lot of open Q&A with the speakers and stuff. So go ahead, Chris.
So Christian Hargraves, I've been doing big data for a while. Today's presentation, there wasn't a lot of time. I found out kind of not a lot of advance, and then I didn't even prepare. So this is a presentation. Should I? Yeah, school's out. So this is a presentation that I did a few months ago at a whole separate conference. And you're not going to see any code.
Alert 2, code trauma, alert 2, code trauma, alert 2.
You're not going to see any code. This is really, so the concepts I talk about are streaming, Spark streaming. I've got about 2-3 years worth of Storm experience where I pulled in the social web and did all sorts of interesting stuff with that. So I'm going to talk about basically complex event processing, streaming, and then for those that are interested, this is kind of like how a lot of organizations get into big data. So and if anyone wants to ask any questions in between, I guess it's just more of a framework of a discussion. If you guys want to ask questions about whatever, feel free to.
Code trauma, alert 2, code trauma, alert 2.
All right, so just a quick piece of what kind of data we're talking about. I don't know if anyone's seen this, but what does, this little piece there, the $1 million, there's a billion, and then, what a trillion is, and that's the types of data sets that we're working with usually. So just some, again, if I'm boring you guys, just let me know. I'll try to skip through these things. But a lot of people think, oh, big data is going to solve my problems. And it might with enough work and sacrifice and sweat and blood. Doctor visits, I don't know. But at any rate, so once you get past all that, it is really enabling. And there's the steep learning curve. There's ways to shorten that learning curve by just doing it.
Code trauma, alert 2. Code trauma, alert 2.
So what I found about Spark is much more enabling and empowering than Hadoop is. It's easier to get up and running. You don't have to understand all the concepts to get going. All right, so it's kind of, again, I'm going to start back in the past a little bit around how we kind of got to where we are. So with the traditional data warehousing, we didn't have a whole lot of data. We didn't have a whole lot of memory. And we decided to, normalize the data a whole bunch, which is kind of the opposite of what you want to do with big data, because you find patterns even in mistakes of the data, right? And abnormalities of it. But at the time, we valued ease of querying over any type of the flexibility of getting the data out in different ways. It was all about speed, and maybe people at the higher level prefer the data to be normalized and aggregated. Tells us a cleaner story. So I have a question for you. Does this look like useless data? What does this look like? It's, pardon me? Yeah, I just made it up, but yeah, that's what it's supposed to represent. So there's all sorts of cool snacks in there, coming from a fat guy. So just some simple things from the IP address. What can we learn? We can learn where they're at from the time, obviously, when it happened. there's, for those that don't know, this is the actual page that was constructed. The 200, I don't know how to use this. The 200 right here represents, that it was a good status code. That's the length of the content returned. That's the page that they were on before they went to this page, and then this was the browser that they used. So now when you try to analyze this and throw this into like a relational database, what happens is you have to choose. You have to choose what data you're going to put in there, because oftentimes there's too many permutations of the data. So for example, the so this TMP didn't have room. That means too many permutations. So what they search for, people can search for millions and millions of different things. How do you throw that into a dimension in a table and expect that to be fast? And you talk to certain business people or certain people about this data, and they're going to say, why do I care about the page number they were on? Why do I care about the actual page result thing they clicked on? Yeah, I probably want to keep where they're from. I can't store this at the level. It's just going to be too many records that I've got, so I kind of normalize that. And so here's an example of if you store every single request for a day, 200 million entries in your database. And if you decide, well, you know what, I'm going to store every minute, then down to like, if you just store the page requests, so for example, there's going to be a bunch of JavaScript and style sheet download and stuff like that in there, then you're going to be down to like 20 million. And if you go down to the minute, you might be into like the single digit millions. So now you've just saved yourself a whole lot of time at the expense of, again, you had to choose the important data points. You can't ask questions around the data that was thrown away. And this piece around the data being pre-aggregated seems like that's a good thing. And for many of the reports that we offer in BI and the BI world, it is a good thing. But when you want to do other stuff with that data and now it's thrown away, you're hosed. And so the argument here is keeping it raw, and that is, I'm not suggesting we throw away data warehousing, but if we do keep the data raw as it was, then here's some things that I've done with the data in my career. Just using weblogs, and we're going to go into a lot more. I just want to talk about, back 10 years ago, weblogs were stuff that everyone threw away, and maybe today people are still throwing them away. But as an example, I was able to improve our page rank on a search by using the data and the collaborative filtering. So I was able to actually recommend products that you probably want to buy based on what people like you have looked at as well. And I didn't add any of this into any of the site. I didn't go in there and program, store this value or store that value or track what this user looked at. This was just all off from logs, and I had no influence on the rest of the development team as to what they wanted to put in. Also autocomplete. Sometimes people will do autocomplete based on what's in the corpus or the words that are in the docs that you're reading. This was actually based on what people search for, right, the most. You can even measure your precision recall on your search based on this. And for user interaction, you might want to know the successful paths. And I did have to add the user ID and the session ID, which was pretty simple. So now imagine this was, actually this is a lot of value. Like I got paid for that, and the companies made money from that. Now imagine if we had some forethought and we said, hey, let's not like the weblogs are great, but we could do a lot better. What if we could store things in a formatted, in JSON or something that's more formatted and it was more standardized? What if in the code, while the code actually has a handle on the user or on the product that they're buying, or they've already queried, they've already got that information, you're not going to be able to get that in normal logs and normal web logs or whatever. What if you were able to just spit that out and say, here's everything I know about the user and the product and the part of the site they're on and whatever, and record event-specific information. So this is kind of jumbled. But back here, if you notice, just one of the bullet points is we're going to record event-specific information not models. So we're not saying a user, hey, I got a page was viewed. That's less interesting, where think of an interaction as a car driving by a sensor and doing a detection on whether they've paid for the HOV lane, or someone going in and purchasing manually in front of the cashier or whatever to pay for that HOV license versus someone going onto the web and purchasing it. Having more, these events can happen all over the place, not just on your mobile app or not just on the web. And batch processes that happen where maybe the auto renewal happens and, hey, this person did purchase it. Oftentimes some of our stats and our information gets lost by having to combine all that. Yeah, so then we can then combine those. So let's say that someone spits out an event that says, hey, the church bells are ringing and the church bells opened and someone's throwing rice and someone threw a flower. We can guess what that is on the screen of the answer, but because, that sounds like a wedding. And so we can put those types of events together, and even though someone didn't, a wedding event didn't spawn, we can say, hey, a wedding's happening because these things happened. Or maybe, example, someone goes in and doesn't log into the account, that failed login 3 times, and now their account's locked. So they call into customer support or help or whatever, and they ask, and they can't give the information that the customer support agent needs in order to help them. That's another event that could be spawned. So we can start detecting that someone's trying to hack into someone's account based on all these events kind of combined. So here's a simple, here's well-accepted architecture for today on storing these events. Who here has heard of Kafka? All right, so for those who haven't, I'll give a quick overview. Kafka, a lot of people, a Kafka is like a queue that you don't delete from. As the messages get old, some period of time passes by, a day, a week, whatever you've told it to, then the messages that are in the queue get trimmed, get pruned. But you can read that same message 500 times, 500 different clients, 500 different people, and it won't get deleted. And so it's this resilient way to store in-order messages in a very fast way. At my previous employer, we were pumping up to 10.5 billion events a day through our Kafka cluster. Now, if you go down to the second, that's a lot. And our cluster was only 10% utilized. That was only 5 nodes. And then we, for getting pumped in through an Oracle batch process system that would auto-renew people, it was getting put in by interactions of the site, mobile interactions, all the stuff I just explained before. You can see each of those pieces here kind of represented. They were all being spawned. Yes?
Were you storing those JSON events?
We were. We came up with a standard JSON format, and we actually there was a framework that was written that would automatically get the header information from the request traffic and or from the request, and it would put it into this message. And then, so even what server they were on, all sorts of information, wouldn't think to track. And then the developers could then put other, pertinent information specifically about that message. But we even had stuff like, this is where the name of the event goes. Everything was standardized. So you can see here a place for the data warehouse. There's, what we did was we would have a job that would run every 5 minutes using Camus. I don't know if you guys have heard of Camus before. It's a LinkedIn MapReduce job that pulls from Kafka and sticks the results in Hadoop. That's all. That's its job. So we can then go back to months and years and do trending and whatnot. So we could pump it in basically usually through Hadoop into the data warehouse. We were working on doing it in Spark. And yeah, that's it for that slide. Any questions on this slide? So I won't go. So the piece here is all the other stuff I already talked about, the derived events. It gets kind of interesting when you start putting those together. So here's an example of different types of events. So let's say that your site, your app, your mobile app, whatever it is, has a search capability on it, and you want to measure how well search is happening. So you can say that somebody did a search here, and I knew what language they were in when they did it. I knew the search term, some unique search ID, what page they were on when they did the search, and then the normal tracking information that might be in there. Then, so when someone provides a search, it doesn't matter if it's mobile, doesn't matter if it's web, doesn't matter whatever, you standardize on the event names and you pump that event out and say a search happened. And part of it would be the, what device was I using here? And then, so what happens when you do a search? A search result page comes back. Well, how do you know that the user, that it was a good search? They click on one of the search results, right? And so when they click on a search result, then you can, because they specifically hit it on that search results page, you could actually have something that says, hey, they found this. In other words, just going to the page is different, right? But recording that they did a search for this search term and they clicked on a page that was represented by that search term and they went there, now you have a derived event that says it was a successful search by putting those two together. So this is where we get into Spark streaming. So you can do events in a batch-only system where originally we were actually doing it once a day, and it took our job 5 hours just to put it into like a Hive table and make sense out of it. We then got it down to every couple minutes we were updating the table throughout the day. And that's a Hive table, doesn't necessarily need to exist in Hive. And you can kind of go back to the original slide that I was going on where you do the pre-aggregation and you store the pre-aggregations. Well, that's something that Spark streaming does really, really well, where you can say these are the cases that happened and here's how often they happened. And you store those somewhere where it can be easily queryable near real time. So who here is familiar enough with, who here even knows the term Lambda architecture? 2, 3, 4, okay, maybe 5. So Lambda is essentially, once you start getting more traffic, you start getting too many writes that you can handle. And there's a certain amount of work that you got to do to display certain amounts of data. You have to support transactions still. They don't just go away. And Lambda is kind of a way to break up your data for some of it to be async. And we could probably talk about Lambda for an hour. So maybe even longer than that. The idea is basically you turn a lot of your stuff into more asynchronous reads and writes, and you have a serving layer that basically someone comes in, they say, hey, what's the latest data? The latest data is populated via a combination of Spark or Storm streaming, pumping it back into that Kafka queue that I was mentioning earlier. And the Kafka queue then pumps it into some intermediate database, for example, that then you can query to key value store and get the data back really, really quickly. And then that data can then be applied back into the warehousing type stuff. So the minute that you throw Kafka in there is the minute that the data becomes asynchronous. So the minute that it could have, half a second or a second or whatever delay, you throw Spark in there, Spark streaming, and the fastest Spark's going to return is 50 milliseconds is the very minimum that they recommend going on the little micro batches. And so has anyone heard of Storm or use Storm? Okay. So how I used Storm in the past was record by record. So a tweet, a Facebook message, a dig, whatever would happen as it came in, I would get one at a time and I would do natural language processing against it. I would do some classification. I would do URL expansions because everyone uses a different URL shortener, and I want to normalize the URLs, extend them, grab the content, grab the title, do some text clustering against it, that type of stuff. I did all of that with Storm. So Storm, when I used it, worked on an individual record. Spark wants you to work on these little micro batches. So you have, maybe you tell it every 5 seconds, I want you to grab the data and do the work of all the code we just saw, do that type of code, map, reduce code, munge the data, aggregate the data, whatever you want to do there. Any questions on this? So imagine you're gonna you're gonna give somebody some hints about stuff that they're looking for. And this is kind of a web page view. And I guess I'm trying to sell the whole concept of events not being just click streams. It's deeper than that, it's underneath that. So if you look at just the click stream, the user sees something in their device or web browser or whatever that signifies they've got something to click on. So the first measurement is, did they click on it? One, where they displayed it, and two, did they click on it? The next step is then, oh, they clicked on it. So they actually viewed the hint. And then what did they do with the hint? Well, they could actually go to the picture of the hint or whatever the hint is. Let's talk about genealogy for a second. It's a census record. So they're now looking at the census record. And if they just stop there, does that mean the hint was successful? Maybe there's some level of success rating you want to give it because it caused the user to interact with the site. But in the end, they didn't adopt the hint right there. So then they go to the hint merge page, which is, yes, I want to add that hint to my ancestor. But there's still a button they have to click that says merge that, right? Merge that in. And the way the site of the company that I was working at had it, once you clicked on that, it just went back to the view page. So you're like, okay, now you're back to your tree, all done. Wasn't so easy to track that necessarily because they could have just went to the tree. They could have clicked on a link on this. So this page right here could have had a link on it, right? That says, hey, go back to your tree. And the refer would have been this page. And so another way of doing this with business event processing is either in the back end. So we found needs for both doing event processing on the click stream. So in the JavaScript, you're saying certain things happen, but also in the back end where those things can happen independent of the device that they're using. So here, when the user arrives, you can actually have information, you know about that user. And you can actually, when you spin your event off, you can actually say, hey, they came from a blog, they came from an internal site, they came from an external site, which is stuff that you can kind of, after a little bit of work, you can find that out if it's just in the clickstream data. But normalizing it too is pretty nice.